Hello everyone, welcome to the Iowa Vegetable Production and Management series. My name is Ajay Nair. I'm an associate professor in the Department of Horticulture and I work on sustainable vegetable production. Know your soil. Don't you want to know your soil a little better? Know what the pH, EC, and the nutrient levels are. The better and the more you know your soil, you will be more effective in managing your crop inputs and getting higher yields and high quality produce. In this presentation, I will talk about two major things. One, I will make you familiar with the soil resources that are out there, especially talking about the Web Soil Survey. It's an incredible tool to know about the type of soil and various other physical and chemical properties that are in the soil. We will also discuss about soil sampling, the appropriate soil sampling technique and procedures, and also deal a little bit into what the soil test reports tells you and how do you interpret it. Web Soil Survey. This is an amazing, fantastic, and incredible resource available to anyone out there who want to know their soil a little better. This is provided through the USDA Natural Resource Conservation Service. What I'm going to do now is going to take you step by step to show what are some of the attributes that you can search for. And of course, you can do a lot with it. So the first thing you would do is just type USDA Web Soil Survey in the Google browser, and you will end up with this page. Once you end up with this page, you would have to click this green button here, which says Start WSS, which means Start Web Soil Survey. Once you click that, you end up on this page, which shows you a map of United States, and of course a lot of highways and interstates. I don't know why, but you know it's fun to watch, look at it. The next tab which you would be clicking is the address tab here on the left hand side. When I click this, I click the address of the Horticulture Research Station, which is down here, and I click enter. In your case, you will put the address of your farm or your field or your plot where you are planning to grow your vegetables. So when I click the address for Horticulture Research Station, here it is. You can see the research station in the middle, some of our buildings, the pesticide building, the shops. We have our research plots out there, orchard here, we have a lake. You will see something, you will see what your field looks like or your exact location. Once you reach that page, the next button which you have to click is the AOI, which is up here. AOI stands for Area of Interest. You can either select your plot as a block, which is this tab here, or if it's an irregular area, you would select this one. So I selected a plot here where I wanted to know more about the type of soil in that area before I put my research experiment out there. Once I drag out there, I see these numbers: 138C2, 138B, 55. These are actually soil types. These numbers are attribute or are assigned to soil types. To know what these numbers mean and what your soil types are, what you would do is click the soil map tab up here. So when you click that soil map, the next thing you see is this legend opening up. So in my case, if you remember, we talked about the soil map, the numbers out there: 55, 138B, 138C2. So I know that 55 is actually a Nicollet clay loam. It's a soil it's an area of my plot which has 1 to 3% slope. 138C2 is a clarion loam, which has 6 to 10% slope. So you can see there's a lot of information out there when you click the soil map tab. Next tab you can explore is the Soil Data Explorer. You can see up here, highlighted here, pointed by this blue arrow. Once you click that, another tab opens. This is at the bottom here. You can see this tab, Intro to Soil, Suitable and Limitations for Use, Soil Properties and Qualities. So next you will click that here. Once you click that, this tab opens here on the left hand side, and in this one you have soil chemical properties, soil erosion factors, health properties, physical properties. There's a ton of information out there. So you can click soil chemical properties, you can click pH, EC, and you can get all that information. So again, Web Soil Survey, an amazing resource, a comprehensive resource to know about the type of soil you are going to produce your crops in. Now, Web Soil Survey does not replace a regular soil sampling and analysis that is more specific and that need to be done before you put a crop in the ground. So this gives a generic idea on the slope, on the EC, pH, but to know what's actually happening in reality, you have to do a regular soil sampling and send it for analysis. So when we send our soil samples for analysis, primarily what we get back are the concentrations of nutrients in our soil. You will see phosphorus concentration, potassium, calcium, magnesium. Those are the macronutrients. And upon request, you can also get the micronutrient concentrations or the levels in the soil: manganese, zinc, boron, copper, iron. And of these, copper, boron, I would say is a little bit more critical when it comes to cole crops. These are a cabbage, cauliflower family. And so you don't have to do the micronutrient analysis every year. What we typically suggest is sampling your soil every year for the major nutrients, which is P and K, calcium, magnesium. You will also get soil organic matter part of that analysis. You will get your EC, you'll get the pH, and we'll talk about that in detail. And for micronutrients, you can do that every 3 to 4 years. So you don't have to spend that extra money to know what the micronutrient level is. Every 3 to 4 year testing for micronutrients is okay. For vegetable production system, the soil need to be sampled at least 6 to 8 inch depth. That would be my soil sampling depth. For most vegetable crops, that is okay. The most important thing I want to mention in this slide, two important things. One is the information from the soil test is only as good as the quality of the sample. So you need to do every bit of every bit of effort and keep things straight when you do the soil sampling. Do it the right way, the scientific way, not just haphazard collect samples, because if the samples were not collected properly, it's not going to reflect in the soil test report. The soil test report means nothing. The second thing I want to mention is fall sampling is preferred. Now, if you are not able to do it, that's fine, but keep in mind, sampling in the fall helps because once you know what's in the soil in the fall, you can take the corrective action in the fall itself. And we will talk about that in detail when we talk about soil pH. So how do we collect soil samples? So what you need to do is to collect a composite soil sample. So here in this image, you can see if this is my field. I took samples 1, 2, 3, 4, 5, 6. So kind of make a W pattern out there. And each place I take one core, I add that core into a bucket, mix all this together, and take one sample out of it. That is my composite sample. You need to make sure that if there are fields which are low-lying, if there's water standing there always, don't mix those samples with the typical field area you have. So keep those samples separate. But otherwise, if the field is quite uniform, just go and sample, make the W pattern, collect those cores, and make a composite sample and send it for analysis. What does the soil test report tell you? It has soil organic matter. It is an important metric for you to know because nitrogen recommendations for specific crops, let's say tomato, cauliflower, cabbage, beans, any of those crops, nitrogen recommendation is made based on the soil organic matter in the soil. The more the organic matter, the less the amount of nitrogen you have to apply during the growing season. Phosphorus and potassium, it's out there. We need that because once we know the P and K levels, then only we can provide specific recommendations for crops. It's not a blanket application. It's based on what is in the soil. For pH, it's absolutely important. Soil test report gives you the pH. We'll talk a bit detail about pH, but pH is required to determine whether you need to add lime to increase your soil pH, or you need to add sulfur or acid-forming fertilizers to bring the soil pH down. So the soil test report will also have cation exchange capacity. It's actually the capacity of the soil to hold on to the cations. And by cations, I mean potassium, calcium, magnesium. Those are nutrients which your plants absolutely need for crop growth, for cell elongation, for photosynthesis, for transpiration, for fruit formation, everything. The soil test report will also have magnesium, calcium, also important macronutrients, EC, which is the electrical conductivity or the salt concentration in the soil, and of course, micronutrients if you requested that in your soil test report. Soil organic matter is important because it is kind of the foundation of your soil. The more organic matter you have, the increased biological activity, and in turn, you will have better soil aggregation. You'll have more nutrients that will be released by the soil. This will all lead to improved tilth and water storage. The more microbial activity, the more good microorganisms in the soil. You will have reduced soil-borne diseases. And of course, all this translates into better plants. And you have good plants, you have good and higher yields and high produce at the end of the growing season. When it comes to nutrients, the Liebig's law of minimum is a great example to define why having optimum nutrient levels are important. You can see this is a barrel with different lengths of the stave. So the amount of water that will be held in this barrel will be determined by the stave, which is the shortest. And in this case, I labeled it as nitrogen. So if it was nitrogen in your plant that was limiting, that will limit the growth of the plant. Irrespective of you having high levels of potassium, magnesium, sulfur, or boron, you can see all other staves are at optimum levels. But if the nitrogen stave was shorter, that nutrient is the one that will be the rate limiting factor and will affect the growth of the plant. So we want to make sure that all nutrients are in the optimum levels. Now, once you get the soil test report back, how do you interpret it? So this is more of a generalization. We at Iowa State University are more than willing and available to help you interpret your soil test report and provide recommendations. But typically when you get the soil test report back, if your soil organic matter is below 3, you are in low. Your soil organic matter is low. If it's 3.1 to 10, it's in the medium range. And if more than 10, it's going to be in the high range. For P and K, you can see the scale we have here. If your phosphorus concentration in your soil test report is between 0 to 10, you are low. 11 to 20, medium. 21 to 30, you are medium to high. 31 to 40, you are high. And 41 plus, then you are in the high level. For potassium, 0 to 120 is low. 121 to 160 is medium. And you can read, if it's more than 241 ppm, parts per million, then it's high. Certain plants need more potassium, for example, tomato, peppers, potatoes. So in that case, even though you might be in the high range, we still need to apply a little bit of potassium. And that's where we step in. So if you have a soil test report, if you want to share it with us, we'll be more than happy to provide you the recommendations for nutrients based on the type of crop you are growing. Now, the holy grail of soil nutrient uptake and availability to the plant is the soil pH, because if your soil doesn't have the right pH, those nutrients, even though they are there in the soil, will not be available. So pH is technically it's the measure of the soil's level of acidity and the single most important factor to know about your soil. That's why it's absolutely important to sample correctly and send the soil samples in to get the soil test report. You might have seen this figure many places. This shows the optimum pH range in which most of the nutrients are available. You can see a pH range of 6 to 7 is ideal for vegetable production. Most of the nutrients, nitrates, potassium, phosphorus, magnesium, sulfur, all of them, they're all, the best range to have is 6 to 7. If your soil pH is high, let's say you're in the 8 range, you might get more calcium, you might get more molybdenum, but you will be missing out on a lot of other nutrients like iron and manganese and zinc, and you'll have deficiency symptoms. So the best way to manage your crop, and again to manage your soil, is to have the soil pH in the optimum range, which is 6 to 7 for vegetable production. How can you adjust your soil pH if it's out of place? If it's 8, if it's 5, or if it's 6 or less than 6. So if your soil pH is high, let's say 7.58, or you will be applying elemental sulfur or acid forming fertilizers, for example, ammonium sulfate. That will bring your soil pH down. If your soil pH is low, let's say 5.5 or 5.6, and you want to bring it between that 6 to 7, the sweet spot, then you would be applying lime. So lime will increase your soil pH. Again, once you provide us with your soil test report or the soil pH numbers, the base pH and the pH numbers, we can provide you the exact amount of the elemental sulfur and the liming material to make sure you get your pH to the right range. So in summary, what I would like to emphasize on is that regular soil sampling is important. It's critical. a good handle on nutrition, and you can only get that by knowing what is in the soil, so you can add what is lacking. You need to also make sure, in addition to fertility, irrigation is properly maintained, because calcium, for example, is taken up by movement of water into the plant, so make sure we have enough water. And again, I mentioned to I forgot to mention this earlier, but fall sampling helps us to get the corrective action. For example, in the case of sulfur, if your soil pH is low, if you know that in the fall, you can I'm sorry, if your soil pH is high and you want to apply sulfur to bring the soil pH down, if you know it in the fall, you can apply the sulfur in the fall, because it takes about 6 to 8 months for that sulfur to act. That's why taking the soil pH in the fall is better as compared to the spring. And finally, maintaining healthy soils, you need to think about the pH, obviously, the electrical conductivity, the biology, and that's why if you see the image behind, it's actually compost. Compost is a great amendment. Not only organic growers, but conventional growers should also be using compost and mixing it with their synthetic supplements or amendments. So healthy soil translates into higher organic matter, higher availability of nutrients, and good quality plants. This will lead to higher yields and good quality produce. Finally, I would like to thank all the partners who help us design and develop these series and do our research and collect data: USDA, NIFA, IFVGA, PFI, North Central SARE for helping us fund to make this series, this webinar series, the Leopold Center for Sustainable Ag. With that, I will leave you with my email, nairaj@iastate.edu, my website, where you can find more videos, more publications, more research reports. Feel free to go and find that information. I hope you found this section on Know Your Soil useful, and you will be diligent about your soil sampling as we get into our production season. With that, thank you very much for watching this video. Until then, goodbye.